Simplify 64 exponent negative 2 over 3 for 3 marks without using a calculator. So the first thing we can do is we can change 64 to its prime base, which is 4 exponent 3, okay? All of that is raised to the power negative 2 over 3, okay? And then from here we can see that these two exponents can multiply each other, so it's 3 times negative 2 over 3, so it's 3 over 1 here. This 3 is on the numerator, this one is on the denominator, so they're going to cancel each other out. We're going to be left with negative 2 over 1, which is negative 2. So it's going to be 4 exponent negative 2, and then finally you can then say 1 over 4 exponent 2, because if it's in the numerator as a negative and the denominator is going to be positive, and then you can further simplify to 1 over 16. So let's simplify for 5 marks. 3 exponent 2n plus 2 minus 9 exponent n minus 1. All of that divided by 2 times 3 exponent 2n plus 1. So the most important thing is to check first whether all of these numbers have been changed to their prime bases. So this has been changed to its prime base, so it's 3 exponent 2n plus 2. It'll remain as it is, and then 9 in its prime base is 3 exponent 2. And then all of that is raised to n minus 1. All of that divided by 2 times 3 exponent 2n plus 1. And then you can then say 3 exponent 2n plus 2 minus, we're going to multiply this 2 with n minus 1. So 3 exponent 2 times n, that is 2n. 2 times negative 1, that is negative 2. And then all of that is divided by 2 times 3 exponent 2n plus 1, okay? And then let's now expand the numerator. So 3 exponent 2n times 3 squared is the same as 3 exponent 2n plus 2 using the laws of exponents. Again, minus 3 exponent 2n times 3 exponent negative 2. All of that divided by 2 times 3 exponent 2n plus 1. So the common factor here is 3 exponent 2n, and then we're going to be left with 3 squared minus 3 exponent negative 2. All of that divided by 2 times 3 exponent 2n times 3 exponent 1. And then 3 exponent 2n into 9 minus 1 over 9, and then all of that divided by 2 times 3, that is 6, times 3 exponent 2n, okay? And then from there we're going to say this 3 exponent 2n and this 3 exponent 2n are going to cancel each other out. We're then going to be left with 9 minus 1 over 9 divided by 6. Okay, and then the common factor or common denominator is 9. So 9 times 9 minus 1 divided by 6. 9 times 9 is 81 minus 1 over 9 times 1 over 6. And then it's going to be 81 minus 1 is going to be 80 over 9 times 1 over 6. 80 times 1, that is 80. 9 times 6, that is 54. So 80 over 54 is the final answer. Now here we're solving for x for 4 marks. Okay, we have the x root of 32 is equal to 128. Now the most important thing here, since we're dealing with exponents, is to change each number to its prime base. So 32 in its prime base is 2 exponent 5, and 128 in its prime base is 2 exponent 7. Okay, now on this side, this is basically the same as saying 2 exponent 5 all raised to the power 1 over x is equal to 2 exponent 7. This is exactly the same as that, okay? And then 2, we can then multiply these exponents, so it's 5 over x is equal to 2 exponent 7. Now, using the laws of exponents, since the bases are the same, we can then equate the exponents. So 5 over x is equal to 7. 5 is equal to 7x. Okay, we multiplied both sides with x, and then we can then say 5 over 7 is equal to x. Solve for x for 4 marks. X exponent 1 over 2 minus 3x exponent 1 over 4 minus 10 is equal to 0. So what we can do here to make things simpler for us, let's x exponent 1 over 4 be equal to k. But over here we have x exponent 1 over 2. So 1 over 2 times 1 over 2 is equal to 1 over 4. Now, it's the same as saying 1 over 2 times 1 over 2 is basically 1 over 2 all squared. Okay? Which means this 1 over 2 is basically k squared. Okay? So you can then come here and say k squared minus 3k minus 10 is equal to 0. And then from here we can use whether it's the quadratic formula or we can use, excuse me, we can use the normal brackets, okay, when factorizing. So the factors of 10, okay, we're going to have k here and k here. The factors of 10 that are going to work for us are positive 5 and negative 2. We can then say, sorry, my mistake, it's going to be negative 5 and positive 2. So you can then say k minus 5 is equal to 0 or k plus 2 is equal to 0. And then solve for k. K is equal to 5, k is equal to negative 2. But remember we said k is x exponent 1 over 4, so x exponent 1 over 4 is equal to 5. And then from here we should raise everything to the power of 4 to cancel this 1 over 4. So raise it to the power of 4 on the left hand side, and the right hand side we're going to be left with x is equal to 5 exponent 4 is simply 625. Now let's try and solve in this part. It's going to be x exponent 1 over 4 is equal to negative 2. This part cannot be solved because this base is a negatives and we can't change it in such a way that it will be helpful to us.